In this video, we're working on two problems similar to another video that we've had on taking the least common denominator and multiplying it to every term in your complex rational expression in order to cancel out all of the inner fractions. But there is another method if you're not comfortable with using the multiplying by the LCD method, and that is to simply find the least common denominator between the numerator's terms and the denominator's terms, and then combine those together and use the copy.flip method to simplify. That's what we'll be doing in this video. So, looking at our two terms in the numerator, we need to find the least common denominator to subtract these fractions, or in this case, this fraction from this whole number. So, we have an x plus 1 here, and technically we have a 1 here, as you can put any number over 1 and it will remain unchanged. So we need to multiply this 3 over 1 by x plus 1 over x plus 1. By doing so, we're going to get a least common denominator between the two and allows us to subtract the numerators. So we'll get 2 over x plus 1 minus 3 times x plus 1 over 1 times x plus 1 is just x plus 1. This is all for the numerator. Now we need to do the same thing for the denominator. In the denominator's case, we have a 2 here and an x plus 1 here. So our least common denominator is 2 times x plus 1. In this case, we already have the 2, so we're going to multiply by x plus 1 to the numerator and denominator, so we don't change the fraction. And here we're going to multiply by 2 over 2. Multiplying by any number over itself is the same thing as multiplying by 1. So this will give us 5 times the quantity of x plus 1 over 2 times the quantity of x plus 1 plus 7 times 2 is 14 over 2 times x plus 1 again. And we did this because now in the numerator we have a common denominator. We can combine our fractions. And in the denominator, we have a common denominator when we can combine these fractions. So we'll get 2 minus 3 times x plus 1 over 5, not 5, I apologize, over this denominator that we had, this x plus 1 that we've been carrying over. Now in the denominator, we're going to combine these fractions together. We have 5 times x plus 1 plus 14 over 2 times x plus 1. So again, we were able to combine these two terms and these two terms since they each have the same denominator now, and they're pairs. Whereas before we could not combine them because they had different denominators. At this point we need to begin simplifying. So moving this up here, we'll end up getting 2 times this 2 plus, I apologize, this negative 3 times x, which is minus 3x, and then negative 3 times positive 1 gives us minus 3 over x plus 1. All over, here we're going to do the same thing. We're going to distribute this 5 to get 5x plus 5. And then we have a plus 14 all over 2 times x plus 1. We can continue simplifying by combining like terms to get negative 3x minus 1 since 2 minus 3 gives us negative 1, over x plus 1. And then for the fraction in our denominator, we have 5x plus 19 over 2 times x plus 1. Now that it's fully simplified, we can use the copy.flip method that says if you have a fraction divided by another fraction, you copy the first fraction down. You then multiply by the reciprocal of the second fraction, which gives us 2 times x plus 1, the denominator we had before, over 5x plus 19. And with this, we can cancel out these x plus 1's, leaving us with 2 times negative 3x minus 1 over 5x plus 19. And it's perfectly fine to leave this in fraction form that is factored, but if your instructor wishes for you to distribute it, then you could just distribute this 2 to get negative 6x minus 2 like we had in the other video. And this is the simplified form of this complex rational expression. Go ahead and take a moment, pause the video, and see if you can try to simplify this complex rational expression using this same method. Okay, so in this case, we can find that the least common denominator between these two fractions in the numerator, between x and 5, is 5x. So we'll multiply the numerator and denominator of the left fraction by 5 over 5, which gives us 25 over 5x, plus over here we'll multiply this fraction by x over x, which gives us 4x over 5x. And now we're going to do the same thing in the denominator of the larger fraction, but we're going to put this 2 over 1, and our least common denominator between 1 and x is just x. So we don't need to do anything to this fraction over here, but this one we need to multiply by x over x to give us 2x over x minus 1 over x. We can then simplify by combining our fraction pairs in the numerator and denominator to get 25 plus 4x over 5x, since we now have a common denominator, all over 2x minus 1 over x. And again, we can now apply the copy.flip method. We have a whole fraction divided by another whole fraction, so we copy the first one, 25 plus 4x over 5x, and we multiply, instead of dividing, we multiply by the reciprocal of the denominator, which is x over 2x minus 1. And now, again, we have a common factor that'll cancel out these x's, leaving us with 25 plus 4x over 5 times 2x minus 1. And again, it's perfectly okay to leave it in a factored form, unless your instructor prefers that you distribute this 5 to get 10x minus 5. But it's also a good idea to order by exponent when possible, so we're just going to quickly rewrite this as 4x plus 25 instead of 25 plus 4x, divided by 5 times 2x minus 1. And that is the simplified form of this complex rational expression.